Okay, good morning. Mr. Kemper here. We're going to talk about drawing some Lewis structures today in a way that I haven't taught you before. And the basis of this is looking at two possible Lewis structures. So let's look at carbon dioxide. CO2, I could draw the Lewis structure like this, and that's the way you've usually seen it. But there is an equivalent way, well, I shouldn't say equivalent, there is another way I could draw the Lewis structure to make it work out. I could have a triple bond between one of the carbons and oxygen and a single bond there. Both of those structures satisfy all the rules of Lewis structures. So which one is the most likely Lewis structure? Well, we have to introduce an idea called formal charge. And on the small board over here, I've defined what formal charge is. So formal charge can be for an atom. That's what we're going to start out, and then eventually it will be formal charge on the entire molecule. So a formal charge is defined as the number of valence electrons in the isolated atom minus the number of electrons assigned to that atom in the Lewis structure of a molecule. That is the formal charge. So a little equation there, formal charge, number of valence electrons in the free atom minus the lone pair electrons then minus half of the shared electrons in the Lewis structure. Okay, so this would be defined right here as the number of electrons assigned to that atom in the Lewis structure. Okay, we'll do an example. So which of these two Lewis structures is more likely? That's the answer, or the thing we want to answer, and we're going to do it by formal charge. So number one, how do we do formal charge? Well, first step is easy. How many valence electrons are in each of these atoms? So from the periodic table, you know that the group number, essentially, is the number of valence electrons. So oxygen is in group 16, so that means the last digit 6 is the number of valence electrons. 6 valence electrons. How many valence electrons are in carbon? It's in group 14, so there's 4 of them. And then this oxygen is the same. There are 6 valence electrons in oxygen. Now in this particular Lewis structure, I need to figure out how many electrons are assigned to each of those atoms in the Lewis structure. So I'm going to follow this little formula right here. And I'm going to subtract this number from the 6 in the case of the oxygen, and I'm going to get the formal charge on that particular atom in the molecule. So let's do the calculation. So how do I find the electrons assigned in the Lewis structure? Well, first of all, I'm going to take the number of the number of lone pair electrons. So here I've got 4 total lone pair electrons. And then I'm going to add to that, actually this should be a plus, sorry. I'm going to put a plus right there. Okay. I'm going to add to that the half of the shared electrons. So how many shared electrons do we have here? Or how many shared pairs? We have 2 shared pairs. Half of that would be 1 shared pair, or 2 electrons. So I'm going to take 2, 4, and then half of those shared electrons would be 2 more, which would be a total of 6. Okay? So the electrons assigned in the Lewis structure in this case is 6. So just add those together for oxygen, and I get the formal charge as 0 in oxygen. Let's do the same thing for the carbon. Okay, we already know that the number of valence electrons is 4. And then I'm going to look at this little part of the equation, the lone pairs plus half of the shared. Well, there's no lone pairs on carbon, so then I just have to count up how many shared electrons and then divide by 2. Well, there's 2, 4, 6, 8 electrons that are shared. Half of those, we would say, belongs to carbon. Okay, that's the formula. So half of 8 is 4. Okay, and then I subtract the 4 from the 4 and I get 0, again for the formal charge. And then this oxygen will be a duplicate because it's exactly the same setup with the double bonds and the lone pairs. So this doesn't look too interesting, but we would say that the formal charge on this particular molecule overall is 0. Okay? Let's see how it's different with the other structure. So we're going to fill in the number of valence electrons for each atom just like we did here. Same exact numbers, 6, 4, and 6. Now things are going to get a little bit different. So I'm going to have to find the electrons assigned to each atom in the Lewis structure. Okay, so again, it's going to be the number of valence electrons in the free atom, 6. We've already got that part. Now we're going to figure out this part. the lone pairs plus half of the shared. So here we've got 2, 4, 6, and then there's 2 electrons there that are shared. So we're going to take half of that, which would be 1. 6 plus 1 would be 7. Okay, so that's the electrons assigned to oxygen in the Lewis structure, that particular oxygen. So let's do the same thing for carbon. We already know how many valence electrons are in the normal atom, just by itself. Then we're going to take how many lone pairs? Well, there's no lone pairs on this carbon. Okay, and then half of the shared pairs. So we have 2, 4, 6, 8 shared pairs. Half of that would be 4. So we would say that the electrons assigned in the Lewis structure there is 4. Then let's look at the other oxygen, which looks a little different. Here it's got a triple bond associated with it. So the number of valence electrons in the normal atom is 6. And then we're going to look at the number of lone pairs. Looks like we've got 2 lone pair atoms. Then we're going to add to that half of the shared. Okay? So then I've got 2, 4, 6. Half of that is 3. 3 plus the 2 is 5. Okay? So that's the electrons assigned to oxygen, that particular oxygen in the Lewis structure. Okay? And now let's just add everything together. 6 minus 7 is -1. 4 minus 4 is 0. 6 minus 5 is 1. So these are the formal charges now. If I add them all together, again, they add up to 0. So there's some rules for deciding which Lewis structure is the best. Number 1, all the formal charges have to add up to 0. Okay? Or the charge on the ion. If it is an ion. Okay, so that works here. So how do we choose which one is best? We look at the smallest number of individual formal charges. Here, every one of the formal charges is 0 for each atom. Here, I've got a -1 and a +1 for formal charges on the 2 oxygens. I'm looking for the smallest numbers. Okay, so the second one is choose the structure with smallest formal charges. Okay, so all of these formal charges are 0. That looks better than -1, 0, 1. So I would say that this is the structure that is most reasonable, even though either one would work with the Lewis structure rules. Okay, so I would recommend that you look in your book. I think it's section 8.9 or 8.10. Look at the formal charge reading there, and there's another example in there to practice this. So bring questions to office hours, and I hope you do well looking at the idea of formal charge. It's only in Unit 2 multiple choice questions, I think, from AP Classroom, but that's an idea that may be covered on the exam, and I never did cover it. And so good luck, and we'll see you soon.